All right, so as you can see, I forgot to change a couple things, but this is Unit 9, Logs and Exponentials, Day 4. So we are graphing logs and exponentials using our transformations. So again, you have these notes. I've given them to you so many times with slight variations to them. We're dealing with A, H, and K. So this base, remember that is the base of our exponent. So if you notice, our exponent and our H is high up tight, up here. The variable and the H are up in the exponent. A is still what's being multiplied to the base, K is still what's being added or subtracted to the base, and your H value is what's happening to X. So these are the notes reminding you of what each of those different letters do to your graphs. And then again, this is how you're going to change each of them. So if there's something being multiplied to your base, when I have you start from the parent function or original function, you are going to multiply that A value to all of your Y values in every single point. H you're going to add to your X value. H is the only thing that changes X. And then just remember that if it's X minus H, you really need to add it because H is positive. If it's X plus H, you need to subtract it because H is negative. The sign's always opposite of what you'd expect. And then back up to the K, if I'm adding or subtracting anything to the base, that again is going to affect the Y value. So I'm just going to add, subtract, or multiply to my X and Y points to get my new points for my transformed graph. All right, so what I'm always going to start you with is a parent function. The base in each of these parent functions will be slightly different. So our base here is 2. So I need to fill in this table for 2 to any power. In your homework, in your notes, there's not going to be a table here. So you just need to know to start with from going from -2 all the way to +2 like we did last unit. So in the calculated, type in 2 to the -2, and you can leave this as a decimal just because decimals are easier to see on the graph. So this is going to be 0.25. 2 to the -1 is 0.5. 2 to the 0 is 1. 2 to the first power is 2, and then 2 squared is 4. So bear with me. I'm going to try graphing this. It's going to be rough. So at -2, I'm going to be at 0.25. At -1, I'm going to be at 1/2. At 0, I'm going to be at 1. At 1, I'll be at 2. And at 2, I'm going to go up to 4. So again, our exponential should always make this kind of ramp. And that's what your graph should look like. There is one thing that we need to add to exponentials. Exponentials have something called an asymptote. And this asymptote, it really just means it has a barrier that this line will never cross. So my asymptote here is going to be this horizontal line where y equals 0. So no matter what my x value is, my y values, these decimals, will never cross into the negative. It'll get close to 0, but it'll never quite hit it. So what we need to do here, I copied, if you see up top, I copied in the parent function table. So I need to take these points and transform it according to these transformations. So the directions say name the transformations, then graph the new points. Well, 2 to the x, remember that was my parent function, so the only thing I added onto here is this -1. That is down off of the exponent, so it's not h. This is going to be my k value. So if k is -1, that means I'm going to shift down 1. So remember, k affects your y values. So I'm going to take all of these y values here, and I'm going to subtract 1 from them. So if I was at -2.25, I'm now going to be at -2, -0.75. This -1.5 will go to -1, -0.5. And then 0, 1 will now be 0, 0. 1, 2 will be 1, 1. And 2, 4 will be 2, 3. So I took every single one of those points and just shifted it down 1 by the y value. If you remember, our original asymptote was at y equals 0. But again, if I have this transformation of -1, that's also going to affect the asymptote. So my new asymptote is going to be at y equals -1. So I'm going to put that dotted line there just to show this exponential will never cross that dotted line. My next one says name the transformations. Again, I have a -1, but that's up in the exponent. So this means my h value is actually a +1. So this is going to shift the graph right. 1. So this time, I'm going to affect the x values. So if I'm going to the right one, that means I'm going to add 1 to all of my original x values. So again, we always go back to the parent function. So at the point -2 and 0.25, I'm actually going to be at -1 and 0.25. -1.5 will be 0.5. 0.1 will be 1.1. 1.2 will be 2.2. And 2.4 will be 3.4. So I still have this ramp shape. It's just shifted over 1. Here, my asymptote's going to stay at y equals 0 because I did not shift the graph up or down at all. So draw in my dotted line over the x-axis. Okay, so this is example 2. These are just slightly different. So I want to name the transformations, then graph the new points. This is actually a brand new transformation here, this -x. We haven't really talked about it, but if you just look here, this is like -1 times x. So remember, h is normally like what we add or subtract to x, but if you just look at your equations, what you do to the points is going to be whatever operation's happening in your equation. So since there's technically a -1 here, I'm going to multiply -1 to all x values. So that's not naming the transformation, that's just telling you what's happening here. So I need to multiply everything by -1. Once we graph our new graph, we'll talk about what happened. So if I multiply all my x values by -1, my new graph will be at 2.25, 1.5, 0.1, -1.2, and -2.4. So what happened here is we actually reflect, but instead of reflecting over the x-axis like we normally do, we reflected over the y-axis. So I just took the whole graph and mirrored it to the other side. And again, my asymptote is still at y equals 0 because I didn't change anything to my y values. For the next transformations, there's actually 2 transformations happening here. I have my a value is 1/2 and k is -3. So I'm going to compress and shift down 3. Sorry to squeeze that in there. So what's going to happen this time is I'm going to, the only thing affected is my y value. So first I'm going to multiply my y values by half, then subtract 3 to them. So half of 0.25 is 0.125. And then if I subtract 3 from that, that's going to be -2.875. Half of 0.5 is 0.25, and if I subtract 3 from that, that's going to be -2.75. Half of 1 is 0.5, and if I subtract 3 from that, I'm at -2.5. Half of 2 is 1, and if I subtract 3, that's -2. And half of 4 is 2, and subtract 3 from that, that's -1. So all of my points should be a lot closer than they were before. So I'm going to go to -2 and -2.8, so just before -3, and then -2.75, and -2.5, -2, and -1. So you can barely see it, but I still have this tiny little ramp. It's just not going to increase as fast. And now because of this -3, that's going to affect my asymptote. So if my original asymptote is at 0, this one's going to be shifted down 3. So it's now going to be y equals -3. So there's 4 examples of how to transform your graphs. So I have 2 examples that I want you guys to finish on your own. So remember, these you need to try on your own. I'm not going to go over these in class. You guys need to have a good idea, because then if your stick gets drawn for class, you're going to have to come up here and do them. So good luck, and I will see you in class.